everybody, welcome to another lecture. Today we are going to be talking about pandas and data science. So just to give you an idea of where we're heading today, this is what our schedule looks like. We're going to talk about pandas. We're going to differentiate NumPy versus pandas, how to read data into pandas, useful functions for panda operations, dealing with missing data, basic statistics, and then my approach to data science, which we'll be using for the next 4 or 5 weeks as we go throughout this unit. So what is Pandas? Pandas is basically just a software package built on top of NumPy, numerical Python. And we talked about NumPy in our last session, and the fact that NumPy basically is just a tool to deal with lists and arrays in Python. So we'll talk about that and differentiate it from Pandas later on. To put it simply though, Pandas is an enhanced version of structured arrays. So it takes NumPy's, adds a cover on top of it, and then lets us read the data differently. And the big benefit with Pandas is that we have row and column headers rather than integer indices. Integer indices is the big thing here that makes it kind of confusing when you have large data sets. So being able to cover those up or mask those in another layer is really helpful for the user. So Pandas is our #1 tool for combing through data and analyzing and transforming and manipulating data for statistical analysis. So what is Pandas used for? Well, Pandas has many applications, but our 3 main purposes here are going to be for cleaning, transformation, and analysis of data. And when I'm talking about cleaning, I'm talking about removing missing values, deleting rows or columns if necessary, like if we receive too much data. When I'm talking about transformations, I'm talking about potentially altering the format of the data, taking a CSV file or an Excel file in, converting it to a data frame, moving columns from a column to a row, deleting empty data, whatever it could be. And then analysis, we have 2 types of analysis we can do with Pandas. We can do our descriptive analysis, which are things like mean, median, max, min, distribution of data, correlation of data. And then we have our inferential data analysis, which would be things like hypothesis testing, PCA analysis, multiple variable statistics, whatever it could be. But to get into those multivariable statistics, we typically add another package on, either maybe scikit or scipy, whatever it is. But for our focus, we'll be primarily sticking with Pandas. So what is the difference between an array in NumPy and a series in Pandas? Okay, because they do have different names. So we talked about an array the other day. An array is basically just a data structure, either in math or computer science, that consists of elements that are stored on integer indices. So basically what that means is if we have a 0 here, because Python is a 0 index language, I have an element that is saved right here. If I have a 1 here, I have an element that's saved right here. And you can see that over here on the top right side. Now, this works just fine, but it can get confusing because arrays are n-dimensional objects that are basically represented as lists in Python. So if you have too many dimensions without a name attached to it, you may confuse yourself. So what Pandas does is it takes that array, which is a really useful data type, and it adds what we call a series object on top of it. So a series is a one-dimensional array of indexed data that can be created from a list or an array. And so it basically takes that array and wraps it in sequences of values and indices that allow us more accessibility to the attributes and makes it more user-friendly. So we can think of this as basically a single dimension within our total data set. So let's take this example on the bottom right here. You see that this says apples 3201. So that's our data. And then outside of there, in these gray letters, we have 0, 1, 2, 3. Okay, so let's imagine this as a plain array. So if I would have just given you this data, maybe it would have said apples, AP, equals, and then we would have had a square bracket, and then 3, 2, 0, 1, and then a closed square. Okay, so if we have apples equals 3201, then we know that we're talking about apples or someone eating an apple, but the 320 and 1 don't have any labels. We would either have to reference another position in our data set or remember off the top of our heads what 320 and 1 are referring to. So what Pandas allows us to do is take this apples array, basically twist it, turn it into a column in a data set, provide it with a header. So now instead of the entire object being called apples, the header of the column is called apples, right? That's more common to what we're used to seeing, the way we're taught math and data these days in school. And then the 3201, we can add names to those rows. So maybe each one of those sub-elements or elements within our object represents a person and the number of apples that they had eaten, right? So that's the benefit of Pandas series. It allows us to add some detail. So in this case, I'll say that Paul ate 3 apples, Juan ate 2 apples, Bethany ate 0 apples, and Robert ate 1 apple. Okay, so in this case, we can add that extra detail that our array would not allow us to. So if that's the case, if a series builds on the array and gives more data, then what do we expect a data frame to do? Well, a data frame basically takes series and adds them together. So think of a data frame as a multi-dimensional array and a series as a single one-dimensional array. Okay, so these are the exact same thing as our arrays and the exact same thing as our series, but just pasted together. So the data frame wraps these sequences of values and indices around the data to provide us accessibility to the attributes by giving them column names and row names and things that make more sense to us. All right, so if we look at this image on the bottom here, you can see it says series plus series equals data frame, right? And that is correct. So on the last example, when we were talking about the apples, I said, okay, the 0, 1, 2, 3, maybe those represent people. Paul, Juan, Bethany, Robert. I don't remember the names I said, but that's what we're going with for now. So if each of those indices represents a person, and then we add another column to it. So the first column's apples, the second column's oranges, right? So now each of those names represents both apples and oranges and how many that person ate for the week. And then we can combine those all into a total data frame. So now we've got our names in one column, our apples in another column, our oranges in another column. So that is the benefit to the Pandas package, is instead of having to remember what each of your sub-elements within your object or your element means, you now have headers, attributes, row names, whatever it may be, to provide you with that detail so you don't have to reference an external source to know what you're doing with your data. So it's that high level manipulation. And we have this in R too. R, the programming language. I teach R also. And in there we use what's called tidyverse. And tidyverse does what it sounds like. It tidies things up. So you can clean, cut, splice, dice, however you may want to, your data. And so Pandas is the equivalent to tidyverse in R, and we will reference the tidyverse package every now and then. So another one of the obvious things that you have to do if you want to do some data science is you've got to have your data, right? And not everybody wants to sit there and take one set of data, like our apples, for instance. Okay, so imagine I have 10,000 data points for the apple column. And in order to get them into my system, I've got to type each number into an array by hand and then turn that array into a series and then turn that series into a data frame with all of my other columns. All right, that's tedious and ridiculous, and you don't have to do that. Pandas is built to directly interact with higher level data sets as long as they're in specific formats. And the nice thing about Pandas is it accepts many data formats. So you can send it a CSV, comma separated vector or file, so like an Excel file. You can send it a text file, you can give it JSON data off the internet or from an API, you can give it a dictionary, you can feed it to a database, and even better than that, Pandas is actually simpler than the built-in modules that Python has to interact with these data types. So for instance, with a CSV, if I was going to work with a CSV in the base Pandas or the base Python module, it would take me 4 lines of code to be able to interact with that file. I would have to give it the file location and read the file in. I'd have to open the file. I'd have to print the view of the file. I'd have to close the file to save CPU usage. Okay, whereas with pandas, it is one single line. It is this top line here. So df equals pd dot read underscore csv purchases dot csv comma index underscore call equals 0. So we give it the name of the file, we give it the index notation if you want to give it an index position. But 4 lines versus 1 line. So it simplifies it down because it's got an exact purpose. And notice how all the other formats are the exact same way. It's 1 line to read it in, it's 1 line to read it out. So that's a gigantic benefit for working with data and manipulating data. It really saves you a ton of time. Useful functions. Okay, so as you guys know by now, in Python, there are always some built-in functions into a package. And most of these, not most of them, some of them we've already talked about. We hit on in the first semester. Some of them we talked about the other day with NumPy arrays because these are extensions of the NumPy function that is being used. So the first 2 are heads and tails. Heads shows you the top of the data set, tails shows you the bottom of the data set, and within those you can specify in or the number of rows that you'd like to see. Info is going to show you an overview of all the characteristics of your data set that you're working with, including data types, titles, columns of the names, if there are any missing data, those kind of attributes. Shape is going to show you the shape of your data, so it's the same as in our array, where it's going to show you how many columns by rows your element or object is. Pandas, not NumPy, Pandas does the exact same thing. Column shows you all the names of the columns in your data set. It sounds silly, but sometimes you'll be looking at a giant data set and make a decision to say, okay, I don't need these 4 columns, and then you forget the names of the columns. So that's just a quick way to pop them up, and then you can either rename them with the rename function, which does exactly what it says, or with the delete function to remove them from your data set. And I think in Python and R, the remove function is literally dot remove parentheses name of the columns you want to get rid of. Is null basically scans the entire data set and runs a column by row matrix to determine if we have a true or false in that cell. So basically, if the cell is empty, it is considered false. If it is true, or if it's filled, it's considered true. Drop NA gets rid of empty cells. So if you just decide, hey, we're just going to get rid of everything that's empty, then you do drop NA, it removes everything from that data set, and that really cuts down on your size. Fill NA does the opposite. It says, I'm going to find the NA, I'm going to find the empty cells in my data set. I'm going to fill it with this specific value based on this metric or this predefined source. And so when we're dealing with missing data, we'll talk about that over the next coming lectures. And this is always a big issue when you approach a project, because if you're working with gigantic data sets, deleting data where you have a missing data point may get rid of your rare data. But if you have a really small data set, deleting missing data really skews your results. So let me give you an example. And this is really important. This is why it's really important that when you're working with data and data science, you are aware of your situation that you're in. So let's say I have an experiment where I only got to run my experiment 10 times. Okay, but in one of the times, I'm missing one of my metrics. Let's say I'm missing the temperature for that day that I ran the experiment. So do I throw that data point away? Because if I throw that data point away, I've thrown away 10% of my total data points for this entire experiment. 10% is a big deal. That's the difference between an A and a B, right? But if I have 10,000 data points and I have 10 missing data points in a data set of 10,000, deleting those 10 missing data points is going to have a much smaller impact unless it's my super rare data, my outliers, that maybe are giving me all of the value, right? So it's important to have this situational awareness when you're discussing your data with your team. Now, there are, of course, many opinions on how to deal with missing data. So some of the most common ones that I have personally dealt with are to just drop all of your missing values. So I had a paper come out last year where we had to do this. We were trying to do basically an economic analysis on organic versus conventional food and how it affects the marketplace globally. And we got down to it in our organic data and realized we were missing like 70% of the data for countries that were second and third world countries. Because guess what? Organic food isn't the number one priority when you don't have enough money to heat your house or clothe your children. Okay, so it's not a concern. The data doesn't exist. And so to us, of course, in the first world country, it's very important to have that data. We really care that these people are getting quality food, but it's not a primary concern for them. So we had to make the decision to just get rid of all the data. Now, one of the other options would have been to replace the data with a specified value. So we could have calculated the mean for a country, replaced it with that mean, and used that to make our comparisons. Or maybe we provide we summarize the whole data. There's different things you can do basically to replace that value and use a different value as a proxy, as long as you do that across the board when you have these missing data points. And that's important because anytime you move a piece of data or manipulate or transform a piece of data, you are manipulating your base data set, which is going to change how you are interpreting the data in your final stages of your analysis. Okay, so you got to keep that in the back of your head the whole time we work through these things. Now let's talk about some statistics. We'll move away from Pandas specifically and into data science. Okay, so we have two main types of statistics that we typically use. We have descriptive statistics, which are things like the mean, median, mode, max, min, interquartile ranges, correlation between different variables, the distribution of the data, those kind of things. So those are really basic. They're just looking at it from the outside and saying, okay, what can I see? What might be sticking out to me already? Like, for instance, if your data is super skewed right, all my data points are super far to the left. I have a really high amount of my data points near 0 and 1 as opposed to like by 100. Okay, so that would be skewed data. Clearly, it's telling you something from the beginning, right? Whereas if it was even, it would be the shape of a bell curve, and that would be evenly distributed data. So those are the kind of things you can see from descriptive statistics. Now, what we spend the majority of our time on in data science is what's called inferential statistics. So this is when you say, I know that this is the standard, or I know that this is the mean, or the proportion of X that happens to Y. Okay, and so what you do is you take that and you say, well, I don't think that's right. So this is my null hypothesis, and I'm going to form an alternative hypothesis. Okay, let's say that X doesn't equal Y, X actually equals Z. Okay, so, and these are just made up. Remember that, these are just made up. So we form our hypotheses, and then we take our data and use our data to make estimates and calculate sample statistics. This is the big one that most people get stuck on. And then we use those sample statistics to make comparisons between our hypothesis and our alternative hypothesis and our null hypothesis to determine if our alternative hypothesis or the null hypothesis is correct. And then we use that to interpret the results and make decisions and pass on knowledge to somebody else. And that is the basics of statistics for data science. And so what we are going to spend the next 4 or 5 weeks on, again, I can't remember, is inferential statistics. We're going to go all the way from the basics of how do I compare two means up through machine learning and eventually to the point where we can have an AI model actually predict the results for us. Okay. Now this takes me to our final slide, which is about our data science approach. So to me, there's two lists of things that I always want to keep in mind when I'm doing a data science project. And I call them the basics and the data checklist. So we're going to start with the basics. Every time you start a project, you should think about these 5 steps, okay? And you're going to work your way through the basics as if it's a checklist. So the first thing is, what is your question or problem that you are trying to solve? Before you even pick up a pencil, before you start Googling and collecting data, you need to know what you want to do. Why would you start an experiment that has no purpose? Why would you waste your own time, right? So we need to know what we're looking for to be able to form a question. And then once we have formed a question to a problem is when we figure out what data is available to help us solve that problem. And if we figure out that we have a bunch of data, but we don't have enough data, then you come to the realization that, oh, I still have to conduct experiments and I still have to collect data. Okay, because that happens many times. I've had friends where they're like, I'm done with this project. And then they do their analysis and they're like, I need 2 more years of data to be able to make a conclusion. And that really sucks. So it's better you figure that out in the beginning than at the end of a project. I promise you. Okay, so that takes us through step 2. Step 3 is to gather and organize all of your data into a single location. That's your CSV file, that's your JSON file, that's your SQL or SQL database, your MongoDB, whatever it may be. However you want to store your data. It could just be a text file that you've written ones and zeros into with commas. Okay, I've had those kind of experiments. But you want to put it all in one place so that you know you have your complete data set there. Next, step 4 is going to be to analyze your data with statistics or machine learning models. A lot of people are preferring machine learning models here, but it's or nowadays, excuse me, but it still requires your input as the user. The computer does not do this for you yet. You still have to tell it what you want it to do. Okay, and then the last step in a data science project is to extract knowledge, analyze the patterns, and make inferences that lead to a gain of knowledge and help you do something or solve some problem. Now, where the data checklist comes in is in step 4. So if we look at it, it says analyze it with statistics/machine learning, and there's an asterisk. So at that point, before you do an analysis is when you need to check your data. Pop over to list 2, the data checklist. Okay, so on the right-hand side here, we have 5 steps to checking our data. We're going to get familiar with the data set. Now, this is in here because there are plenty of people, if you go to grad school or you're involved in data science later in life, what you'll realize is there are plenty of people that just, they don't understand the math or they don't understand the computer side of it, one or the other. And so they'll send their data off to somebody to analyze it. And that's completely fine. But in many cases, that data that they send has the most minimal amount of information possible. Okay, you might just get a header for each column and each row, no definition of what kind of measurement was taken, no information about what the variable was, no information about the environment, no information about where the experiment was conducted. You know, all of those little things, while they may seem like I'm being nitpicky, they do add up. If I just send you a blank text document or a text document with some data in it, it's like, well, how am I supposed to clean it? If I don't know what problem I'm trying to solve, how am I supposed to clean it, right? So that's step 1. You have to get familiar with the data. You have to know what you're talking about to be able to gain knowledge from that data. Step 2, you're going to check for structural errors. And this might not make sense right now, but it will once we start practicing. When you're checking for structural errors, basically you're checking to make sure that the person that did the research or organized the database stored the data in the correct format and the correct structure, because sometimes people think that data makes more sense as a column, as basically an array, but in actuality it would make more sense as a row, so as an attribute to an array. Okay, and we'll learn more about that in a little bit. So it's like saying, let's say we were looking at an analysis of a bunch of different metrics. Let's say gross domestic product, how many things an economy is producing, total number of apples produced a year, total number of oranges produced per year. And so those are my rows. Okay, so I've got my rows like this. And then my columns are the countries. Okay, so we've got the countries up and down in my columns, and then my rows are my variables, or what I would say are our variables. And what you'll realize is that doesn't make sense. What would make more sense is to flip them. It'd make more sense to have the countries as individual elements within our arrays, and for our arrays to represent the variables that we are measuring. Okay, so that's what I mean by structural errors. Sometimes you got to flip-flop things and manipulate the data into a form that is usable for you, for the problem you're trying to solve. Number 3 is to check for irregular formats. And this happens a lot. So you'll get through maybe 3/4 of an analysis and get to the point where you're actually ready to do statistics. And you're like, okay, well, my entire data set is read in as a text file, because that happens sometimes, and you don't convert until you get there. And then you go to convert from a text file or text input type into an integer type, because you're dealing with numbers. And when you make that conversion, it doesn't work. And then you read through your data and you realize you have float data in there, right? So it's all these little nuances that you might not catch if you just start working on the document. You need to check those things at the beginning. Make sure everything lines up, cross your T's, dot your I's. Number 4, what do you do with the missing values? This is always one of the hardest questions in any project. Sometimes it's easy, sometimes you just delete them, right? But in other instances, it's a big issue. And then lastly, document the changes you made to the data and the effects that they will have on the project. Okay, so this may seem nitpicky, especially if we're working in a development environment where we're passing versions through Git back and forth to each other. But in cases where someone emails you a document, which is much more common, or an Excel file, which is much more common in academia, this is where that matters. Because when you open that document, it's going to pop open on your screen, and it's going to automatically take you to the top of the document, not the place where the person left off. And by taking you to the top of the document, you have a chance at that time to catch the viewer or the person that you've sent the file to and provide them with some key information. So at the top of all of my data science projects, I always put my basics. Okay, I put what problems I'm solving, what type of data to have, what each variable means at the very top in a commented section, and then I put my checklist also. So I can always remember to check my checklist and see if the other person left any issues that need to be addressed on the data set. Okay, so it's kind of like a quick catch up. Where you, as the new person working on this data science project, have the opportunity to learn a bunch before you dive in and go, oh my gosh, I hate my life, right? So that is my approach to data science. We're going to be practicing this until we get to the end of this unit. If anyone has any recommendations or extra steps they'd like to add, please just let me know. I'm always happy to take comments. And then as far as our lecture for today goes, that's all I had for you. I hope you guys have a wonderful day, and I'll see you next time.